Okay, today we're going over transforming quadratics. In this video, we're just going to focus on vertical transformations, okay? Vertical transformations of quadratics when looking at an equation is the most intuitive one. It's pretty logical. Now, the first thing we need to realize is exactly how to draw the original or the parent function here. Y equals x squared. Now, we could do this by a table. Okay, we make a quick table on the side here. And we can plug our values in. These would be our x's and our y's. Okay, and we can plug in some values. So we're going to do this. We'll start at -2, -1, 0, 1, and 2. These will be the x values we'll plug in. I'm going to do this quickly. Okay. What this means is we would plug these x values in for x in this equation. So, -2, what is -2 squared? So what is y when x is -2? +4. Good. Okay. -1. -1 squared is +1. So what is y when x is -1? Good. 0 squared. Good. 1 squared. 2 squared. Okay. I want you guys to see that there's a bit of a pattern here. Each of these is a coordinate of this graph. Okay. We're going to plot these points over here. So at -2, we were at +4. -1, we're at 1. 0 is 0. 1 is 1. And 2 is 4 again. Okay, so we haven't extended this, and I'm going to in a second. But this is our shape. From what we talked about yesterday, where's the vertex of this? 0 and 0. 0 and 0 is the vertex. In other words, it's the lowest point. Okay? And that's of any time we have this function here. Okay? This is very important. We need to know how to graph that specific function. That's one that has no changes to it. It's almost like you call the original one. They sometimes refer to it as the parent function. Now, I want to show you a pattern in order to graph this. One way we could do it is because there's no changes to this, we always start at the vertex, and depending how far away we move from the vertex, we square that number. Okay? So if I start at the vertex and I move 1 away, what is 1 squared? So I know to go up 1. Go back to the vertex. If I go in the positive direction 2, what's +2 squared? 4. So I got 1, 2, 3, 4. Okay? So -1 squared is +1, so we went up 1. -2 from the vertex is +4. So, with that information, if I were to go 3 from the vertex, how far do I go up? 9. We square 3. And if I were to go -3 from the vertex, still 9. See how this is a symmetrical shape? Okay? Extend it a little. Vertex is at the origin for this one always. Okay? So, that's our original one, and we're going to talk about how this can change. Okay? The first changes we're going to talk about, and I want to refer to things. Now, this form here is very important. If you guys see this, this is a quadratic formula, but we haven't really seen it in this matter yet. This is called the vertex form. Okay? Vertex form. So, in vertex form, we're able to see the vertex very easily. Okay, the vertex is actually at whatever h and k are, whatever these numbers represent. But what we're going to do is we're going to take this parent function and we're only going to apply one of these transformations. Today we're just going to apply the k transformation. So I've taken x squared, which is down here, and I'm just going to add k to it. What k does is it shifts the entire parabola up and down. Okay, k deals with vertical transformations. That's what we talked about vertically. So if k is a positive term, the parabola goes up. If k is a negative term, the parabola goes down. Simple as that. All right? And it goes down and up by the exact number of units of k. So depending what that k value is. So in this case, let's say I were to give you this equation. We'll do it in red. Y is equal to x squared plus 3. Okay? What that means is this original parabola here is going to go up 3 units. We start at the vertex. Now, one way to do it is I always suggest to draw the original one. This original one we've drawn in black, which represents y equals x squared. Make sure you know how to draw that. Very important, because when we talk about transforming something or moving it, we're talking about moving it from here. You need a reference point. This is our reference point. We're going to be moving this parabola, the one we just said, the x squared plus 3. We're going to move it. Well, positive 3 means we're going to go what direction? We're going to go up, and how many units? 3 units. Okay. So in other words, this parabola here, I take the vertex and I go up 1, 2, 3. The new vertex is here. Now there are 2 ways to finish graphing the rest of this. I can take each of the original points I've had before and go up 3 from there. So up 1, 2, 3, 1, 2, 3, and then 1, 2, 3, 1, 2, 3, and continue this pattern. Okay, the thick ones are the ones that we're going to be using. Or, because we know how to draw this parabola from the vertex, I can apply my rules I did at the bottom. I had my vertex. If I go over 1 from the vertex, how much should I go up? 1. 1 squared is 1. If we go over 2 from the vertex, how many should we go up? 2 squared. So 2 squared is 4. We go up 1, 2, 3, 4. Okay? Same vertex. We go over 3. We go up 9, which would be off this graph. Okay? So those are 2 tricks in how to draw this. Now, the easy part of graphing is we connect the dots. So this red one represents y equals x squared plus 3. Okay? Let's say I give you another one. And just to try to make this as all-encompassing as possible. So, in reference to the original y equals x squared, what is this green equation? Y equals x squared minus 10. What's going to happen to it? It goes down 10 units. Okay, so down 10 units. So our vertex is where now? All the way at negative 10. Now I can go all the way down from all of those points, but personally I find it much easier to just go from the vertex upwards. Okay, so from this vertex I go over 1, how much do I go up? Okay, 1 squared is 1. And it's a symmetrical shape, so whatever I do to the one side, I do the same pattern on the other. I go over 2 from the vertex, how many do I go up? 1, 2, 3, 4. Same pattern over here. Okay? I purposely drew the bottom so we can try to get as much of this parabola on this graph as possible. So, I go over 3. 1, 2, 3. How many do we go up? 9. That would be way up here. I go over 4. 1, 2, 3, 4. How much do we go up? 16. That is up here. Okay? And then if I were to go over 5, how many would it go up? No, 25 is off this. Okay, I don't have 25 off. But this is the shape of the parabola. Oh, I shifted this one a little too far. Let's go back there and fix that. So always make sure you're going over 1. Up 1, so we went over 1, 2, 3 should be at 9, and 4 should be at 16 here. There you go. That's why I was stretching it. Now, mine isn't the smoothest curve. Did that freehand. But that's the idea of the parabola. Now, let's show you what that would actually look like in our graphing program. Okay, we have this graphing program here. It's a great idea to test it out. So, x squared. That's what x squared looks like. Let's actually move over, center this, and maybe even zoom in a little. Okay? Here's our x squared. Add another one. In this one, we're going to have x squared, what did we say? Plus 3? Plus 3. Sorry, that's supposed to be a lowercase x. There we go. So if you notice, we've moved 1, 2, well, 3 units. Each of these squares goes up by 2. Okay? So this parabola has been shifted up 3 units. And the third one we did was y squared, sorry, x squared minus 10. And if you notice, this is 10 down from the original. The original being our blue one. The red one shifted up 3 units. The green one shifted down 10 units. Okay? So feel free to use this program. These are vertical shifts. We've only dealt with one type of shift. We're going to go with 2 others after this.